Let us move on to the next problem on binomial distribution, that is question number 8. The question is, a coin is tossed 6 times. What is the probability of getting at least 4 heads? Okay, 6 times. First of all, we have to consider coin tossing 6 times. Whenever we consider the coin tossing experiments finite number of times, we can take it as a binomial distribution with p equal to 1 by 2. So here 6 times means that n equal to 6. Now we have to obtain the even at least 4 heads. At least 4 heads in this sense 4 or more heads. Okay, 4 or more heads. That is what is the value of x. If we consider x as the number of heads, x takes values from 4 up to 6. That is greater than or equal to 4, isn't it? X greater than or equal to 4 probability is required one. Okay, so simple to solve the problem. We have to assume x as the number of heads out of 6. Therefore, x follows binomial n equal to 6, p equal to 1 by 2. And now we obtain probability x greater than or equal to 4. Okay. So, let x be the number of heads out of 6. Therefore, x follows binomial n equal to 6, p equal to 1 by 2. Okay. Implies f of x equal to 6x into 1 by 2 raised to x into 1 by 2 raised to 6 minus 6 equal to 6x into 1 by 2 raised to 6. 1 by 2 raised to 6. Okay. Now we require the probability of at least 4 heads. Therefore, probability of at least 4 heads, in the sense probability x greater than or equal to 4, isn't it? X greater than or equal to 4. That is equal to probability x equal to 4 plus probability x equal to 5 plus probability x equal to 6. That is equal to this 1 by 2 raised to 6 is 1 by 64, isn't it? And here x takes values 0, 1, etc. up to 6. That is probability x equal to 4 is 64 into 1 by 64 plus 65 into 1 by 64 plus 66 into 1 by 64, isn't it? 64, 65, 66. These are to be obtained. So 1 by 64 into 64 is 62. As we know, NCR equal to NC, n minus R. 62 is 6 into 5 by 1 into 2, that is 15. Okay, 6z5 is 6z1, which is equal to 6. And 6z6 is 1, that is 15 plus 6. 15 plus 6 is 21 plus 1 is 22 by 64. It is 22 by 64. The answer. Okay. So that this problem is solved. That is simply when we consider the coin tossing experiments, we can take it as binomial. With if otherwise stated, we consider these coins are unbiased. So probability of getting a head p equal to 1 by 2. Now it is required at least 4 heads, so that in terms of x it is probability x greater than or equal to 4, which means that probability x equal to 4 plus probability x equal to 5 plus probability x equal to 6. And we are after on calculation we get, on simplification we get the probability as 22 by 64. Okay. Now we consider the next one. It is given that the question is The question is, if 20% of the balls produced by a machine are defective, determine the probability that out of the 4 balls chosen at random, case 1 is 1, case 2 is 0, case 3 is at least 1 bolt will be defective. That is, we are given out of 4 balls, X as the number of balls defective, number of defective balls. And we are given 20% balls are defective. That is probability of a defective being 20 by 100 equal to 0.2. Okay. So that we consider question number 9 and let X is defined as the number of defective balls. Number of defective balls. Out of 4, okay. So that we may assume it as a binomial distribution. Then P as the probability of a defective. So equal to 20 by 100 as equal to 0.2, okay. Therefore Q equal to 1 minus 0.2 is 0.8. That is, X follows binomial as N equal to 4, P equal to 0.2. Hence, we can obtain f of x as, which implies f of x equal to 4zx. As we consider out of 4 balls the number of balls defective, N equal to 4, okay. So that 4cx into 0.2 raised to x into 0.8 raised to 4 minus 6, and x is the number of defectives, so taking value 0, 1, 2, 3, 4, okay. Now simply probability of one defective. Question number 1, part 1 is probability of one defective. So probability x equal to 1. Okay, so 4c1 into 0.2 raised to 1, isn't it? Into 0.8 raised to 3, 4c1 into 0.2 raised to 1 into 0.8 raised to 3. So the answer is 0.41. You may check for calculation, okay? And now the question number part 2. What is part 2? Here we have to substitute in this function. So I will keep f of x. Now part 2 is probability 0 defective. Okay. Probability 0 defective. 0 defective means, what is it? Probability x equal to 0. Probability x equal to 0, we know it as q raised to n, isn't it? So equal to 0.8 raised to 4, 0.8 raised to 4, and the same value as equal to, on simplification we get 0.41, okay. Now part 3. What about part 3? It is probability of at least one defective. You have to consider this event at least one defective. At least one defective means minimum one is defective. That is probability. The required one is x greater than or equal to 1. Isn't it? Check. Probability x greater than or equal to 1 means probability of at least one is defective. That is probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3 plus probability x equal to 4. As x takes value 0, 1, 2, 3, 4, if the complementary event for this probability, for this x greater than or equal to 1 is x equal to 0, isn't it? So that we may write this as 1 minus probability x equal to 0. So it is 1 minus 0.41, okay. So it is It is 0.59, isn't it? 0.59, yes. Okay, so that this question is solved. Okay, now we consider the other one. Question number 10 is, can a binomial distribution have mean 4 and variance 6? Mean 4 and variance 6. Now we know the very important property of binomial distribution is mean equal to NP, variance equal to 6. X follows B and P implies we have mean equal to 6, mean equal to NP, variance equal to NPQ. Okay, variance equal to NPQ. And what is the property? As Q is a fraction, as it is a value less than 1. Okay, thus mean always should be greater than variance. Okay, so that this implies mean greater than variance. Now here, what about the values? Here, mean equal to 4 and variance equal to 6 is the contradiction to this result. Okay, here mean less than variance. As it is not possible, the statement is not true. Okay, so we write, since mean equal to 6, mean equal to 4 and variance is 6, it is given. The given statement is wrong. The given statement is wrong. Since here, as here mean less than variance. Okay. This is the property of binomial distribution. This is the very important property of binomial distribution, mean greater than variance. As in the statement, mean is less than variance, the statement is wrong. Okay, so that we go to the next question. Now the next question is, the probability of a man hitting a target is 1/4. If he fires 7 times, what is the probability of his hitting the target at least twice? Okay, so that we consider n as equal to 7 and x as the number of times he hits the target, so that we can consider it as a binomial distribution, and p is taken as 1/4. Okay, so let x be the number of successes, number of times he hits the target, the person hits the target, and p equal to probability of a success. So equal to, we may take p equal to 1/4, that is x follows binomial n equal to 7 and p equal to 1/4, isn't it? Therefore, f of x equal to 7cx. X is the number of times he hits the target, so 7cx into 1/4 raised to x into, what about q? Q is 1 minus 1/4, that is 3/4. 3/4 raised to 7 minus x. Now what are the values of x? X equal to 0, 1, etc. up to 7. Okay. So what is the probability of his hitting the target at least twice? We have to consider this event, target hitting at least twice. So at least twice means 2 or more times. Okay, 2 or more times he hits the target. That is, we can assume we can take the event as probability x greater than or equal to 2. Required probability is probability x greater than or equal to 2. At least twice he hits the target. Okay. So we may assume it's complementary event 1 minus probability x less than 2. It is 1 minus probability x less than 2. So that it is equal to, what about 1 minus probability x equal to 0 plus probability x equal to 1. This total to be subtracted 1 from 1, isn't it? 1 minus bracket probability x equal to 0 plus probability x equal to 1. Now 1 minus, we know probability x equal to 0 as equal to q raised to n. Okay. So it is 3 by 4 raised to z1. 3 by 4 raised to z1. Plus probability x equal to 1 as 7c1 into 1 by 4 raised to 1 into 3 by 4 raised to 6. Okay. 3 by 4 raised to z1 plus 7c1 into 1 by 4 raised to 1 into 3 by 4 raised to 6. This is the answer, and you can simplify. The next question is, we consider the next one. The next question is, in a binomial distribution consisting of 5 independent trials, the probabilities of 1 and 2 successes are 0.4096 and 0.2048 respectively. Find the parameter p of the distribution. We can assume x as binomial. What about 5 independent trials? So n equal to 5. Okay. That is, we assume x follows question number 12. The previous one was question number 11. Okay. Now question number 12. So that, what about, let x follows binomial n equal to 5 and p is to be obtained. The value of p is to be obtained. You are given probability of 1 and 2 successes. That is p of x equal to 1 as equal to, what about, 0.4096 and p of x equal to 2 as equal to 0.2048. Okay. So that we may take this equation, that is f of x equal to 5cx into p raised to x into q raised to 5 minus x. X equal to 0, 1, 2, 3, 4, 5. Okay. Now probability x equal to 1, probability x equal to 2. We may take this as 1 and this as 2. So now we may proceed. 1 divided by 2, what happens? It is simply 5c1. Okay. Into p raised to 1 into q raised to 4. Isn't it? Divided by. Then probability x equal to 2 is 5c2 into p square into q cube. That is equal to 0.4096 by 0.2048. It is equal to 2. 0.4096 by 0.2048 equal to 2. You may check. Now this means that 5c1 is 5. Okay. And 5c2 is 5 into 4 by 1 into 2, which is 10. This implies 5 by 10 into, here the remaining factor in the denominator p, and in the numerator 1q remains. Okay. Q raised to 4 by q cube is q in the numerator, p by p square. So p in the denominator, that is equal to 1 by 2. 5 by 10 is 1 by 2, isn't it? And that is q is 1 minus p. This implies 1 minus p by 2p equal to 4, equal to 1 minus 2p by 2p equal to 2, which implies, this implies 1 minus p equal to 4p, isn't it? That is 1 equal to 5p, which implies p equal to 1 by 5 equal to 0.2. So the required value of p is 0.2. Okay. Okay. We have answered 12 questions. We have solved 12 questions. Okay. Thank you.